Let's continue our study on measuring instruments by looking at time, mass, and weight, and the instruments used to measure them. From our previous lesson, we learned that a micrometer screw gauge is used in measuring the diameter of a wire, the thickness of a paper, and the diameter of a small ball. A micrometer screw gauge is used for short readings between 0 and 2.5 centimeter. The reading accuracy of the micrometer screw gauge is 0.001 centimeter or 0.1 millimeter. A micrometer screw gauge has two scales. The first scale is known as the main scale, and this scale is located on the sleeve, whereas the second scale is known as the circular scale, also called the vernier scale, and this is located on the thimble. Now let's jump into our lesson for today, measurement of time. Time is defined as an interval between two successive events. The unit of time is in seconds. Also, other units of time can be in minutes, days, hours, weeks, months, or years. It is also good that we note that 60 seconds is equal to 1 minute, 60 minutes is equal to 1 hour, and 1 day is equal to 24 hours. In the laboratory, time is usually measured by a stopwatch or a stop clock. Take note. In the laboratory, we use a stop clock or a stopwatch to measure time. Also, it is good that we note that time has the accuracy of 0.1 seconds. The stopwatch or the stop clock has an accuracy of 0.1 seconds. It's good we take note of that. Also, nowadays, quartz clocks and atomic clocks give a high degree of accuracy. So this is what the stopwatch or the stop clock looks like. The diagram or the figure represented on this page is what a stop clock or a stopwatch looks like. Measurement of mass. Mass is defined as the quantity of matter a body contains. Mass is a scalar quantity. Mass remains constant from place to place. The SI unit of mass is kilogram. Mass is usually measured by comparing it with standard masses. Mass is measured using a beam balance and also a chemical balance. This is what a beam balance looks like. On this page, we have a clear figure of what the beam balance looks like. This is also what the chemical balance looks like. This is a clear representation of a diagram showing the chemical balance. Measurement of weight. Weight is the amount of gravitational force acting on a body or the force with which a body is attracted towards the center of the earth. The weight of a substance varies from place to place due to gravity over places. Weight is a vector quantity. The SI unit of weight is Newton, and weight is measured using a spring balance. So weight is a vector quantity, whereas mass is a scalar quantity. So I have a lesson on scalars and vectors. Do well to go back to that lesson in order to understand what scalars are and vectors are and the clear differences between them and also examples. This is what a spring balance looks like. This is a clear diagram of the spring balance. You can look at this diagram carefully. It's clearly labeled. If this lesson has helped you, don't forget to like, share and subscribe to Easy Physics with Omonye for more simplified physics lessons. I will see you in the next lesson.